Here we are with our next topic, integration. Once more, the disclaimer, this video is for the integrated math students of the Navy's Sixth Form College. They have the handout and will be following along. Here goes. Integration. This is the reverse of differentiation. The integral of a gradient function gives the equation of the curve. So like it says, integration is the opposite or the reverse of differentiation. If we differentiate a y function, we get dy dx. So in reverse, if we integrate that dy dx function as you see here, we will get that y equation. This sign is called the integral. So the integral of a gradient function will give you the y equation. So the general formula to integrate a function in the form ax raised to the power of n, you simply add 1 to the power and divide by that answer, and you put a plus c at the end. Now this formula can only be used for functions where the power is not equal to -1 and the coefficient of x is not equal to 0. Let's look at some examples. So we have the integral of x cubed dx. Now this dx simply means that we're integrating with respect to x. So following the formula, we're going to add 1 to the power, then divide by that answer and put a plus c at the end. So if we add 1 to 3, we get 4 as you see, and we divide by that 4. It's quite simple. We put a plus c at the end. Here, in the next example, the integral of 3x raised to -4. If I add 1 to -4, I will get -3, and I divide by that -3. Simplified, 3 divided by -3 is a -1, making our answer minus x raised to -3 plus c. Now, like I said earlier, integration is the reverse of differentiation. So if I went ahead and differentiate this answer, remember this is the y that I'm getting. So if I go ahead and differentiate this answer, I should get back this dy dx function. So let's try. So following the rule for differentiation, -3 times -1 is a +3. Write back the x variable. And if I subtract 1 from that power, I do get -4, which we started out with. So it is in fact the reverse. Now let's look at the next example. 2/5 x raised to the 7. If I add 1 to this 7, I get 8, and I divide by 8. Now, this 8 can get this is now 1/8 in fact. It gets multiplied by this coefficient of 2/5 that we had before. So 2 times 1 is 2, 5 times 8 is 40. So our simplified answer becomes 1/20 x raised to the 8 plus c. In our fourth example, the integral of root x. Now we know root x can be rewritten as x raised to the power of half. So following the rule, if I add 1 to a half, it's the same as adding 2/2 if you don't want to use a calculator. It's quite simple. So we keep the denominator the same. So if I add 1 to a half or 2/2, I get 1 plus 2, 3/2. And I divide by that 3/2. Now this can be simplified by multiplying by the reciprocal. So dividing by 3/2 is the same as multiplying by 2/3, which is the upturn of the function of the value we had before. So now this answer becomes 2/3x raised to 3/2 plus c. In our fifth example, it says the integral of 6x raised to 3/4. So if I'm adding 1 to my 3/4, it's the same as adding 4/4, which gives me 7/4, and I divide by that 7/4. Once again, this will go up as the reciprocal, which is 4/7, and when it gets multiplied by the 6 that was there initially, we get 6 times 4, 24, over 7. So this is our answer, 24 over 7 x raised to 7 over 4 plus c. Just some quick note. Back to differentiation. We know that if we differentiate a constant, we get 0. So in reverse, if I integrate that 0, I should get a constant. And that's what this is saying, that the integral of 0 equals c, which is a constant. Now the integral of 1 is going to be x plus c. In the same way, the integral of 2 is going to be 2x plus c. The integral of negative 3, negative 3x plus c. So we're simply adding an x to the constants when we integrate. Now, what we have next are some questions from an exercise. Now, we won't be doing all. I put an asterisk at the questions that I chose from number 1 I chose E, H, and K. Now I have them done on this paper and we're going to go through them. So we have, I wrote down H first, which is the integral of 3, and like I was saying earlier, I will simply add an x to this constant. So the integral of 3 will be 3x, and we add our plus c at the end. Now you might be wondering why we keep adding this plus c. That's because this topic is indefinite integral. And if we go back to differentiation, I realize I'm doing that already, but it's key. If I differentiate 2x plus 5 and 2x minus 3, they're separate functions. But the thing is, the derivative of each of them is 2. So notice that these constants are different. So that's why when we integrate, we put a plus c at the end so that later on we can find the value of that constant. Okay, so let's continue on. In our next question, we want the integral of negative 4x. So like we have been doing, we're going to add 1 to the power. So this x has a power of 1 already. So when I add 1 to the power, I get 2 and I divide by that 2. So my simplified answer, 2 into negative 4 is a negative 2. I forgot my negative sign. So this should be negative 2x squared plus c. Next question. The integral of negative 1 over 3x squared. So going ahead, we add 1 to our power. So 2 plus 1 is 3, and we divide by this 3. So now the coefficients, negative 1 times 1, and then 3 times 3 is 9, making our answer negative 1 over 9 x cubed plus c. In number 2, I chose to do questions D, G, and L. So, question D, if I add, question says the integral of negative 6x raised to negative 4. So if I add 1 to negative 4, I get negative 3, and I divide by that negative 3. So negative 6 divided by negative 3 will give you a positive 2, making our answer 2x raised to negative 3 plus c. In part G, this x squared is brought up, so now the function is rewritten as the integral of 3x raised to negative 2. Following the rule, add 1 to the power. This will give me a negative 1. I divide by that negative 1 as well. So simplified, 3 divided by negative 1 is a negative 3, making our answer y equals negative 3x raised to negative 1 plus c. In the next question, we have the integral of 2 all over 3x to the power of 4. Now we are only going to bring up the variable. So this 2 over 3 is left as a constant, and this x4 goes up as x raised to negative 4. So now when we integrate, add 1 to the negative 4 power to get negative 3, and we divide by negative 3. So now when we multiply the coefficients, 2 times 1 is 2, 3 times negative 3 is a negative 9, making our answer y equals negative 2 over 9 x raised to negative 3 plus c. In question 3, I chose to do E, F, G, and K. So first we have E, which is the integral of negative 3 root x. So my root x is rewritten as x to the half. And now we can integrate. We add 1 to the half, or add 2 over 2 to get 3 over 2, and we divide by that 3 over 2 as you see here. This 3 over 2, like we did earlier, goes up as 2 over 3, and now we have negative 3 times this 2 over 3, and these 3's will cancel, making it a negative 2, and then the x raised to 3 over 2 goes back like we had initially. So now our answer is negative 2x raised to 3 over 2 plus c. In question F, this is the fourth root of x, which is rewritten as x raised to the quarter. So we go ahead, add 1 to our power to get 5 over 4, and we divide by 5 over 4. This 5 over 4 below gets brought up as 4 over 5, making our answer y equals 4 over 5x raised to 5 over 4 plus c. In question J, we have 6 all over 5 times the cube root of x. Now, like we did before, we are only going to take up the variable. Now, this cube root x is the same as x to the 1 over 3. So when it goes up, it becomes x raised to negative 1 over 3. So now we can integrate. Add 1 to negative 1 over 3, we get 2 over 3, and we divide by that 2 over 3. This 2 over 3 gets brought up as 3 over 2, so when it gets multiplied by the 6 over 5, simplified, we get 9, 3 times 3, 9 over 5, and x raised to the 2 over 3 plus c. In the last question, K, we have the square root of x cubed. So now, this x cubed is under the root sign, so the entire thing gets raised to the half, which now reads as the integral of x raised to 3 over 2 dx, because we simply multiply the powers when it's in this form. So 3 times a half is 3 over 2. So now this is what we're integrating. So when I go ahead and add 1 to this power, I get 5 over 2, and I divide by 5 over 2. And now this goes up, making our answer y equals 2 over 5, x raised to 5 over 2 plus c. In question 4, I chose C, J, and L. So, part C says the integral of x cubed minus 1 dx. So it's just going to do each value separately. So if we integrate x cubed, we add 1 to the power to get 4 and divide by that 4. And if we integrate negative 1, we'll get negative x, or negative 1x. So this becomes our answer. Y equals x to the 4 over 4 minus x plus c. Now this can also be written as a quarter of x raised to the 4. In part J, we were given the question 2x raised to the 6 plus 8 over x to the 5. I went ahead and rewrote the 8 over x to the 5 as 8x raised to a negative 5 after this gets brought up. So now let's integrate. We add 1 to this power of 6 to get 7 and divide by that 7. We add 1 to this power of negative 5 to get negative 4 and divide by that negative 4 plus c at the end. So when I simplify, this is the same as 2 over 7x raised to the 7. But since this is a positive divided by a negative, we get 8 divided by negative 4 and negative 2, and we write back our x raised to the negative 4 plus c. In part L, the integral of 5 over x squared minus 2 minus 2x cubed. I rewrote this 5 over x squared as 5x raised to the negative 2 as this get brought up. So now when we integrate, add 1 to negative 2 to get negative 1 and divide by that negative 1. Integrate this negative 2 to get a negative 2x. If I add 1 to the power here, 3 plus 1 is 4, and I divide by that 4. Plus c goes at the end. So my y equation can now be rewritten as minus 5, because a 5 divided by a negative 1 is a minus 5. So once more, minus 5 x raised to the negative 1 minus 2x, and if I simplify 2 over 4, I get half x raised to the 4 plus c. In question 5, I chose to do E, I, and K. Okay, so in part E, it's the integral of 4 root x minus 2 all over 3x squared. First, I rewrote my function. This 4 root x is 4x to the half, and this x squared gets brought up, making it now a 2 over 3 x raised to negative 2. So now let's integrate. If I add 1 to half, I get 3 over 2 and divide by that 3 over 2. If I add 1 to negative 2, I get negative 1 and divide by that negative 1. So now when we simplify, this 3 over 2 gets brought up as 2 over 3. So when it gets multiplied by the 4, we get 4 times 2, 8 over 3. We have a negative 2 over 3 here divided by a negative 1. So a negative divided by a negative makes this a positive 2 over 3. And that's our answer. 8 over 3 x raised to 3 over 2 plus 2 over 3 x to the negative 1. And it can also be rewritten. It can also be written as 2 over 3x, as this x to the negative 1 can be brought down as x to a positive 1. In question I, the integral of 4 all over 3 times the cube root of x minus 2 times the 7th root of x. First, we are rewriting our function because we need the power. We need it as a numerator. So now, once again, we are only going to take up the variable. So this cube root of x is the same as x raised to 1 over 3. And it will be brought up as x raised to a negative 1 over 3. This 7th root of x is the same as x raised to 1 over 7. So now we can integrate. If I add 1 to a negative third, I get 2 over 3, and I divide by that 2 over 3. If I add 1 to 1 over 7, I will get 8 over 7, and I divide by that 8 over 7. So now when we simplify, this 2 over 3 gets brought up as 3 over 2, and this 8 over 7 gets brought up as 7 over 8. So when we multiply or simplify, these 3's will cancel, and 2 into 4 is 2, making our answer 2x raised to the 2/3 minus 2 into 2, 1, 2 into 4, 2 into 8, 4, 7 over 4, x raised to 8 over 7 plus c. And now for question K, the integral of 2x to the 3rd minus 3x raised to 4 over 3 minus 5x raised to 7 over 3. Nothing to rewrite, so let's just go ahead and integrate. Add 1 to a third, we get 4 over 3, we divide by 4 over 3. Add 1 to 4 over 3, we get 7 over 3, divide by 7 over 3. Add 1 to 7 over 3, we get 10 over 3, and divide by 10 over 3. So all we have now is to simplify. This 4 over 3 goes up as 3 over 4, so this is now simplified as 3 over 2. This 7 over 3 goes up as 3 over 7, this becomes 9 over 7. And this 10 over 3 goes up as 3 over 10, gets multiplied by the 5, making it 3 over 2. So this is our answer. 3 over 2, x raised to 4 over 3, minus 9 over 7, x raised to 7 over 3, minus 3 over 2, x raised to 10 over 3, plus c. Now, in question 6, as you can see, we have functions being multiplied. Now the thing is, with integration, there is no product rule. So when you have a function like this, you simply expand or remove the bracket and then you integrate. I chose to do question F, H, and J. Okay, so in question F, we have the integral of x to the third times 2x plus 3 times 2x plus 3. So when we multiply, we add the powers. So 2 times 1 is 2. So 2, going again. So 2 times 1 is 2. And now the power of x becomes 4 over 3. Because 1 over 3 plus 1, or 1 over 3 plus 3 over 3 is 4 over 3. So once more, x to the third times 2x is 2x to the 4 over 3. And then x to the third times 3 is 3x to the third. So this is now the function we are integrating. And as before, we add 1 to our power. This will give us 7 over 3, and we divide by 7 over 3. Add 1 to a third here to get 4 over 3, and we divide by 4 over 3. This goes up as 3 over 7 and gets multiplied by the 2 to give 6 over 7. This goes up as 3 over 4 and gets multiplied by this 3 to be 9 over 4, making our answer 6 over 7, x raised to 7 over 3, plus 9 over 4, x raised to 4 over 3, plus c. In question H, we have the integral of x plus 3 times x plus 5. So when we remove our brackets, x times x, x squared. X times 5 is 5x, plus 3x is 8x, and 3 times 5 is 15. Now we can integrate. Add 1 to this power of 2 to get 3, divide by 3. This x already has a power of 1, so when we add 1 to it, we get 2, and we divide by that 2. And this 15, which is a constant, we will simply add an x next to it. So our simplified answer becomes x cubed over 3 plus 4x squared, as these get simplified, plus 15x plus c. In question J, we have the integral of 2 times x plus 5 all squared. Now, to open this x plus 5 all squared, there is a formula, if you recall. A plus b all squared is equal to a squared plus 2ab plus b squared. So we're going to let our ab, our x be a, and our b be 5. So now let's open this bracket. So we are going to get a squared, which is x squared, 2 times ab, 2 times 5, or 2 times 5 times x, which is 10x, and then b squared, 5 squared is 25. or you could just go ahead and expand it as x plus 5 times x plus 5, whichever you're more comfortable with. So the expanded function for this we have here, and we're going to multiply it by the 2 that we have outside. So this becomes 2x squared plus 20x plus 50. So when we integrate, we add 1 to this power to get 3 and divide by that 3. Add 1 to this power to get 2 and divide by that 2. And our 50, which is a constant, we simply add an x to it plus c at the end. So our simplified answer, 2 over 3x cubed plus 10x plus 50x plus c. Lastly, we have number 7, and I chose to do f, h, and j. And if you look at these questions, the functions are being divided. Yes, they are being divided, and there is no quotient rule, so we're going to simplify, then we integrate. Okay, so for f, we have the integral of x minus 4 all over x cubed. Now, yes, we can bring this x cubed and raise it to a negative 3, and then multiply by the x to the 4. So you can do that, but it's simpler to separate and give each of the values the same denominator. And I'm going to show you why a little later. So I'm going to give this x the denominator of x cubed as well as the 4. So these are the same functions. Now we can simplify. When we are dividing functions, we subtract the powers. So now this is 1 minus 3, making it x raised to negative 2. And this, no power to subtract, so we simply bring this x cubed up as x to the negative 3. So this is now the function we're going to integrate. So add 1 to negative 2 to get negative 1 and divide by negative 1. Add 1 to negative 3 here and get negative 2, and we divide by negative 2 plus c at the end. So simplified, this becomes a negative x raised to the negative 1, and then a negative 4 divided by negative 2 is a positive 2, and then our x raised to the negative 2 goes back plus c. Question H, we have the integral of 4x cubed minus 3x squared all over 2x. Now once more we're going to separate and give each of them the denominator of 2x. Now this is why I chose this method. Now if I was to bring this 2x up, this 2 should also be raised to a negative 1, not just the x, and that will make things a little more difficult. So that's why it is easier to separate and give each of them the denominator. So when I do that and simplify, 2 into 4 is 2, and when we divide, we're going to subtract the powers. So 3 minus 1 makes this an x squared. So we have a 2x squared here. Here, the power of 2 minus 1 gives us x. So we have 3 over 2x. So this is the function we are now integrating. So following the rule, add 1 to the power of 2 to get 3 and divide by 3. Add 1 to this power to get 2 and divide by 2. So our simplified answer becomes 2 over 3x cubed. This is 3 times 1, 3, 2 times 2, 4. So this becomes minus 3 over 4x squared plus c. And in our final question, we have the integral of 6x minus 3 all over 2 root x. Now 2 root x is the same as 2x to the half, and we gave each of these the denominator. So simplifying, 2 into 6 is 3, and when we divide or subtract the powers, 1 minus a half is half. And this x to the half, remember variable alone, goes up as x to the negative half as seen here. So now we can integrate. Add 1 to a power of half to get 3 over 2 and divide by 3 over 2. Add 1 to negative half and get 1 over 2, divide by 1 over 2. So when we simplify, this goes up as 2 over 3. So 2 over 3 times 3 gives us 2. Write back our x raised to 3 over 2. This half goes up as 2 over 1. And when we multiply by this 3 over 2, we get 3. And this x half goes back. So this is now our final answer. Y equals 2x raised to 3 over 2 minus 3x to the half plus c. So that right there is our introduction to integration. Just simply remember, when we're integrating, we add 1 to the power, and whatever answer we get, that's what we divide by. And we put plus c at the end.